All right, moving on to our trigonometric integrals. We did one, if not this exact one, in class as part of our review. This question has multiple ways to do it, so multiple correct answers. The smarter, more efficient way is to peel off one of the cosines because then we have a lot less algebra in our future. So let's just go ahead and rewrite this. Sine to the 7th cosine squared, and then we have our cosine of x dx. And as I've said 1,000 times in class, the kind of goal of a lot of these trigonometric integrals is to identify what your du would be, because then that's why we peeled off the x, that cosine of x. We know that we need to have a u that is equal to sine x. No need to change here and address because the derivative of sine is positive cosine. So if only we could rewrite this cosine squared as sines, we'd be cooking, right? We'd be ready to go. And that's where our beautiful Pythagorean identity comes in. This is 1 minus sine squared x. So be sure to use parentheses if you're going to use this and take a step to write it out with that Pythag identity. But you could also just jump straight to the u's. We're now at u to the 7th, 1 minus u squared, and our du. Gorgeous. We need to distribute so that we can actually use the power rule, because right now we still have a product, and that's not very helpful in antiderivative land. So let's go ahead and distribute that u to the 7th. U to the 7th times 1 is u to the 7th. U to the 7th times 2, u to the 2nd is u to the 9th. All right, and now we can use the power rule to rewrite this. U to the 8th over 8 minus u to the 10th over 10 plus c. And then one final step to rewrite this back in our u. Sine to the 8th of x over 8 minus sine to the 10th of x over 10 plus c. Boop. That's our trigonometric integrals. The only way this gets more exciting is if we had done the other version, or if I give you something like a cosine to the 5th. Just be sure that if you were to go the other way, when you have to do this u minus u squared cubed, I'm trying to think, we'd still have 3 of these cosines, and we'd have a negative out in front. You'll get to something like this. Ensure that you are actually distributing out everything that was inside those parentheses to that power. So you might have to take something like a sine to the 7th power and rewrite this as sine to the 6th times sine of x, and then rewrite that sine to the 6th as sine, we don't want it cubed first, we want it squared first, squared of x cubed times sine of x. Just keep that sort of in mind, that you will maybe need to do a little bit more algebra than just this distribution we saw here. You might have to distribute a squared term, distribute some binomials squared before you can distribute out any remaining u to the whatevers. So there's our first trig integral. I'll do the next one in a different video.